Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. And we are here doing 91B in your Saxon Orange Book, and we're talking about spheres. And we'll talk about the volume of a sphere and the surface area of a sphere. Now, a sphere is a perfectly round 3D shape. Think basketball. A basketball is a great example of a sphere. So here is my little rendition of a sphere to try to show you that it is indeed a round object. And then from the center of the sphere out towards the outside, touching the outside of the basketball, is the radius. And the cool thing about the sphere is that radius distance is the same everywhere on the sphere. Because it's right in the center of this basketball. So we have some formulas that we need to learn. The first one is volume, and volume is 4/3 pi r cubed. Now this one is easy for me to remember because I know that volume is always in cubic measure. Remember, the volume of a rectangular solid was length times width times height, and we always had inches cubed or centimeters cubed or something like that. So that's easy for me to remember that the radius will be cubed. And so this is the formula. But there is also another way that you can think about the volume. The volume of a sphere is 2/3 the volume of the cylinder that exactly encloses the sphere. So let's see that just real quickly. So here, I'm going to make a cylinder that exactly encloses the sphere. Okay, and I know, well, that didn't look like a very good cylinder, did it? I'm drawing. Oh well, you'll just have to pretend with me that that's a straight up cylinder. Okay, so 2/3 the volume of the cylinder. But remember, a cylinder is area of the base times the height. Well, the area of the base of this cylinder is a circle. Okay, and the circle is pi r squared. The area of the circle is pi r squared. So pi r squared, and then times the height. Well, if this is exactly the height of the basketball, and this is the center, then it's going to go up a radius, and it's going to go down a radius. The diameter is twice radius, isn't it? So that height is going to be 2r, and then we're going to take 2/3 of that. So we're going to take this, and we're going to multiply all of this by 2/3. Now let's see what happens if we get this when we simplify all of this. Okay, so let's think about it. We have an r and an r squared. R times r squared is r cubed. So we have an r cubed. We have the pi. And we have 2 times 2/3 is 4/3. So if you ever forget the volume of a sphere formula, you can say, well, I know how to find the volume of a cylinder, and I know that that basketball is 2/3 of the cylinder volume that would exactly enclose it, and that's how you can get the formula. The other thing that we need to know, another formula, is surface area of a sphere. The surface area of a sphere is 4 pi r squared. Remember, area is in square units. So for me, it's easy to remember that volume is r cubed and surface area is r squared. Okay, but it's 4 times pi r squared. So basically 4 times the area of a circle is going to be the surface area of the sphere. And these formulas, their proof is outside the context of this class. You will learn how to come up with those formulas better when you get a little higher up in math. For right now, we need to learn how to memorize those formulas and also use those formulas to find the volume and surface area of a sphere. Okay, so here's our first example. Find the volume of the sphere whose radius is 3 centimeters. So again, we need to know volume is 4/3 pi r cubed. We know that our radius is 3 centimeters, so it'll be 4/3 pi 3 centimeters cubed. Okay, well, centimeters times centimeters times centimeters is going to give me cubic centimeters. And then 3 times 3 times 3 is 27. So I'm going to have 4/3 pi times 27 centimeters cubed, or cubic centimeters. Now, I'm going to, instead of multiplying 27 times 4, which would take some brains, I'm going to cancel 27 and 3, which is much easier. So I get a 9. So 4 times 9 is 36 pi centimeters cubed. Okay, now this is the exact answer. That's exact. Now, we're supposed to use a decimal equivalent, but remember with pi, it's a decimal approximation. So we're going to use 3.14 in place of the pi, and that's going to be 36. So we're going to have 36 times 3.14. 4 times 6 is 24, and that's going to give me an 8 and an 18 and a 12 and a 4 and a 9, 4, 10, 13, 11, 2 decimal places. So 113.04 cubic centimeters would be the answer. Okay, now I thought this little diagram might be helpful to you. They're just trying to get you to have a picture in your brain of 4 circles, because the surface area of a sphere is 4 pi r squared, which is pi r squared plus pi r squared plus pi r squared plus pi r squared gives you 4 pi r squared. So the area of 4 circles that are exactly the same radius as the original sphere will give you the surface area. So they were just trying to give you a picture to help you remember that formula. Right, so here is our example. Surface area is 4 pi r squared, and we're looking for a surface area of a sphere that has a radius of 4 meters. That's a pretty big sphere. 4 meters is the radius. And a meter is bigger than a yard, isn't it? It's about 39 inches. And that's just the 4 of those is the radius. So 8 meters would be the diameter of that sphere. Pretty large. Large beach ball. Okay, so we're going to find the surface area, which we know is 4 times pi r squared. Now our r is 4 meters, so let's go ahead and take our 4 meters. Okay, and I always like to leave my pi in until the end, because that gives me my exact answer, and then I will substitute in 3.14, which gives me a good approximation. So 4 pi, and then 4 squared is 16, and then meters squared. And 4 times 16 is 64 pi meters squared. So the exact surface area is 64 pi meters squared. But we're going to get the approximate, which is often more useful to us than having a pi sitting there. So we're going to plug in the 3.14 and multiply. So we're going to have 64, and we're going to have 3.14, And when I multiply, I get 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. 3 times 4 is 12. And then I'm going to multiply by 6. 4 times 6 is 24. 6, 7, 8, and 18. So then when I add, I get a 6, a 9, a 10, a 10, a 2, 2 decimal places. Okay, so I get 200.96 meters squared. 200.96 meters squared is the surface area of a 4-meter radius sphere. All right, so the last video, we did A, B, and C on your practice with 91.A, and so we only have 2 problems to do for our practice for the 91.B. We're almost done. So the first practice is D. It says find the volume of the sphere that is a 4-inch radius. And so we're going to say volume is 4/3 pi r cubed. And so the r is 4 inches. So 4/3 pi 4 inches cubed. All right, so we know that 4 cubed is 4 times 4 times 4, which is 64. 4 times 4 is 16, and 16 times 4 is 64. And then inches cubed times the pi times the 4/3. Okay, now 3 does not go into 64 evenly, so I'm going to have to do a little bit more math here. So I'm going to go ahead and multiply this out. 4 times 4 is 16. Carry my 1. And then 4, 24, 25. 256 over 3 pi inches cubed. Okay, so now we're going to multiply and then divide to get this all in the correct form. So we're going to use 3.14 here. And we're going to leave this one in this form until we multiply, and then we'll divide by 3. Okay, so we're going to go ahead and slide in. We'll move our inches cubed down. We'll change this to a 3.14. And we're going to come over here on the side and do 256, 3.14. See if I can get that a little closer. I got a shine on my window from the window. Shine on my board from the window. 6 times 4 is 24. 22. 8, 9, 10. And then by 1 it's just going to be 6, 5, 2, isn't it? And then 6 times 3 is going to be 18. Carry the 1. 5 times 3 is 15, 16. Carry the 1. 2 times 3 is 6, 7. And add those all up. 4, 8, 13, 7, 8, 9, 10, 8, and 2 decimals. So 803.84 divided by 3. Okay, so we have to divide all of that by 3. And I'm going to move this because it's in my way. I'm going to move this right here. So divided by 3. 3 into 8 is going to go 2 times. 2 times 3 is 6. And I get a 20. 3 into 20 is 6 times. 6 times 3 is 18. And I get a 2. Okay, and I get a 2, 3. So 23, 3 into 23 is 7. 7 times 21 from 23 is a 2. 2, 8. 3 into 28 is 9 because that's 27. So 1, 4, 3 into 14 would be 4. Okay, so we have 267.93, 267.94 inches cubed. And there you have it. Okay, let me get the glare off the board there. Can you see all of that work? It was a lot of work, wasn't it? And I went ahead and did it on the calculator just to make sure, and we were correct. The next digit when we divide is a 6, though, so we would round the 94 up to a 0.95 if we were rounding. But it really didn't tell us how to round that, did it? So just remember that one was an example. If they were giving you that as a problem, they would tell you where to round it. But I'm going to let that answer stand for right now because I just didn't keep on carrying it out. All right, we have our last problem here, our last little practice problem. Surface area of a sphere whose radius is 5 feet. So remember that the surface area is 4 times the area of a circle, and the circle has to have the exact same radius as the sphere. So the sphere is a 5-foot radius. So we're going to take this R, put 5 foot, and then squared. So 4 pi R squared is our formula. 4 pi, 5 squared is 25. Foot squared, or square feet. 4 times 25 is 100 pi square feet. We can go ahead and write square feet here. Now, we have an easy one, don't we? Because pi, we're going to put as 3.14, but 100 times 3.14 simply moves the decimal 2 places to the right. And we wind up, this 100 moves this decimal 2 places to the right. We end up with 314 square feet. Now that one was nice and easy. All right, so you are ready to go off and do your assignment. This is Mrs. A, and may God bless your day.